Hey you guys, hello everyone, welcome to Saurav Sir's classes. Today we are in the session of tomato problem solving subjective portion. So tomato is basically the book Test of Mathematics at 10+2 level, published by East-West Press, Indian Statistical Institute itself. So this is a very important book for all I.S.I aspirants. This is because this book is published by I.S.I itself, and I.S.I expects every student to be thorough with this book, the approach of the problems. There are many problems, a bunch of problems in this book, including objective and the subjective. You need to go through them. Now I.S.I paper, entrance paper, usually has two sections, the objective and the subjective portion, and you need to qualify in both of them. So your first stage is the objective portion which you need to qualify, and then your subjective papers will be checked. So today I am back with the subjective questions. So subjective questions in I.S.I are usually tough unless you get the concepts properly. And for that you have exciting range of Saurav Sir study materials for I.S.I and CMI. Those are really very helpful in problem solving, and it covers a vast problems from Olympiads all over the world, which will help you to succeed in I.S.I CMI examinations. So now we are back into problem solving session, and without wasting further time and without further ado, let's just see the first problem of this day. So it says the derivative f of r to r is continuous. So it says the derivative of this function is continuous, and we have indirectly told that the function f is differentiable, and 0 less than equals to mod fx less than equals to half. Prove that the sequence an defined by a1 equals to 1, an plus 1 is f of an for all n greater than equals to n is bounded. So you need to prove that such a sequence when defined is bounded. So we need to understand what the question says. It says that the derivative of the function is continuous. The function's derivative, f's derivative is continuous and is bounded in this interval 0 to half. So we need to prove that this sequence which is defined by this is also bounded. So I give you some amount of time to try it out on your own, and then later we will discuss the solutions. Okay, so the stipulated time given for this problem is over. So I hope that many of you could solve this problem while some could not. So those who could, please tally your answer, and those who could not, just see the concept that I am introducing. So this problem is a very direct problem that I.S.I has asked. So this direct problem and can be solved directly using some manipulation tricks. So what do I use basically is that, so since f dash x is said to lie less than equals to half, so I can say that f dash x lies between half to minus half, which further implies that if I integrate, so you know that the integration is very much well allowed. So this is a constant of the integration, f0. So half an minus 1 plus f0 less than equals to an. So I just rubbed up this x. And you can very well understand what is meant by the statement. Okay, so this is just a direct manipulation and computation as per in the question conditions given in the question. So now we consider the right hand side of the equation. So RHS, so we are considering the RHS. RHS we get an less than equals to half of an minus 1 plus f of 0, which is less than equals to half of half of half, and it goes on. So which I can say that observing the pattern, I can say 1 by 2 power n minus 1 into a1 plus 1 plus 1 by 2 plus 1 by 2 square plus 1 by 2 power n f of 0. So sorry I reached up till there, so I must move the board for you to be clear, which is nothing but less than equals to 2 plus 2 into f of 0 if you compute the geometric series and just manipulate it. From the LHS, if similarly, so I just write it similarly and leave the calculations to you, we get an greater than equals to minus 2 f0, and hence f is bounded. So we can say that hence an is bounded where the m chosen is so this was the m that is chosen. So please have a view so that you can get a clarity of the problem. Now, so what is the core concept behind this problem? The core concept behind working this problem is the modulus inequality. We know that mod of x is less than equals to a, then the solutions is, if mod of x is less than equals to a, then the solution is x less than equals to a greater than equals to minus a. That we have used. Integration of our inequalities in both sides are preserved, so there is no as such usual way that the inequalities can be broken. And of course simple manipulation techniques. So you need to know the sum of a GP series, you need to know simple manipulation techniques to solve these kind of problems. So this was a very cliche and straightforward type problems from I.S.I. So now we will get into a much more trickier problem. So let's get to the trickier problem then. So we have increased the level of the problem, and this is the second problem for the day. Show that the number of ways in which one can choose a set of distinct positive integers, each smaller than or equal to 50. So distinct positive integers each smaller than or equal to 50 such that their sum is odd is 2 power 49. So just try this problem and then I'll explain you the trick that is involved in the problem. So please try it for the stipulated time that is given. Okay, so the stipulated time that was given for this question is over, and now I will discuss the solution with you. So now, for this problem, since this is a bit trickier, I want to explain you about a very important concept. This is the concept of fixed point. So what is a fixed point? Suppose in a set, you have a function defined from the fs to that set. So if f of I equals to I in that set where I belongs to S, then I is a fixed point. So now what we can do is sometimes we usually choose our fixed point specifically so that it helps in us, and sometimes the fixed point is given in the question. And this point method, I have named it, is fixed point method of proving problems. So now I will prove this tricky problem by fixed point method. So what is a fixed point? Let me just repeat it. So f is a function from S to S. So f of I equals to I for some I. So there exists I belongs to S such that f of I equals to I. So this symbol is there exists. Then we say that I is a fixed point. This is the definition of a typical fixed point. For example, let me give you example. That if say f of 1, 2, 3, 4 to f of 1, 2, 3, 4, I just made say f of 1 equals to 1, f of 2 equals to 3, f of 3 equals to 4, and f of 4 equals to 2. So what is the fixed point here? So 1 is said to be the fixed point here. So this method is called as fixed point method, and what I will teach you today is a method regarding fixed point. In later parts of mathematics, you will be able to learn what a fixed point iteration is and how you utilize them in combinatorics and dynamical systems. So now let's get started with solving the problem. Okay. Now for solving the problem, we need fixed point idea. So the set of integers that is given to us is what? The set is 1 to 50. So this is the set that is given, and we are told that the sum is odd. Now what I do is, I say 1 is the fixed point. It means 1 is fixed. Okay. Now if 1 is the fixed point, then I consider a set without the fixed point. Say that set is S dash. So how many numbers are there in S dash? So the size of S dash is 49. In how many ways can we select 49 subsets? That is, how many subsets are there of S dash? 2 power 49. Now just hold a bit. Now if in 2 power 49 subset, you have a subset whose sum is an even number, what do? Your 1 was left out, just include the 1 there. I hope I am not very clear, so let me just explain. The subsets are of this form. So these are the form of the subsets. So what I do is, the sum is straight to be odd. So 2, what is the sum of the subset? 2, which is even. What I do is, I supply a 1 here. 3, the sum is odd, I don't do anything. 4, the sum is odd, even here. So what I do to make odd? I have that one fixed point left. So I just supply that 1. So I get 4 plus 1 equals to 5. So in this way, we see that the selection of 1 or the fixed point is in a single way only. And the rest of the selection is 2 power 49. And therefore, the number of selections is 2 power 49 into 1, which is 2 power 49. Proved. So you see that how fixed point method could solve the very big problem in a very shorter way. So the big problem was presented in a shorter way by fixed point method. And now I will demonstrate more methods to you with one more problem so that things get very clear. So I usually forget the duster. So now I'll get to the next amazing problem from I.S.I. So a function f is derivable in 1 to infinity. So this is from the test of mathematics. This is the test of mathematics book. So question, a function f So it says that a function f is derivable in this interval. So a function derivable in this interval is that. So we see that in that interval the function is a very smooth curve, and about the other parts of the in the real number system we don't know. So we will talk only about this interval with f1 equals to 1 and f dash x equals to 1 plus x squared. So we need to show that. So I give you a stipulated amount of time to try it out on your own. Okay, so the stipulated time given for this problem is sufficient enough. I think that this is much a straightforward problem to be solved. So now before solving this problem, let's gain some intuition regarding the problem. A function is derivable in 1 to infinity. So what does this suggest? That what can be the function? Of course the function is something positive. Okay. Why do we see that the function is positive? This is because the function is differentiable in 1 to infinity. Other parts we cannot say, but we can say that since f1 equals to 1, then we can just see or imagine or visualize a graph of the function which is in the interval of 1 to infinity. Okay? Now, we are given f dash x equals to x square plus f of x whole square. What does it mean? It means that f dash x is positive for all x. F dash x is positive for all x. And what does that mean? It means that since f dash x is positive for all x belongs to real number, if f dash x is positive for all x belongs to real number, then fx is increasing. So what we need to find is an increasing function which is positive, and that is an intuition, or this serves as a hint for the entire question to come. Now see the magic that how we will solve this question with just keeping these two hints in mind. So we are given that f dash x is f of x whole square, which implies f dash x. So fx is increasing. So this is the first statement to be made. Therefore, f dash x, which is equals to x squared, which is equals to 1 by x squared plus f of x whole square, which is less than equals to 1 by 1 x squared plus 1. This is further can be integrated in interval 0 to any arbitrary x, and the sign of the inequality remains the same, and that is 1 by 1 plus x squared. What is the integration? This integration is fx minus f1 and so you see that how easy the problem become with the intuition that we have gathered about fx is positive and increasing. And how did we do the step? We know that fx is greater than equals to 1 since fx is defined in 1 to infinity, and we know that fx is greater than equals to 1, and so we could just follow this sequence of steps. Now to conclude this video, I want to say that today we have learned a number of tricks, many tricks we have learned, and I tell you or instruct you to utilize these tricks in exam. Remember that these tricks are very invaluable tricks and can be just incorporated in any exam for problem solving, because these are the crux strategies that involve in subjective problem solving. But for this understanding, for the proper understanding of these crux strategies, you must try more I.S.I problems by yourself. And when you try more problems using these strategies, you can easily clear the I.S.I entrance examinations. And not only Tomato or Test of Mathematics will help you to clear I.S.I. So there are materials, rich amount of materials from Saurav sir's classes, which are available online and even via the center. So you can purchase them, and you will just find many Olympiad questions are listed there in Saurav sir's classes, and you can find immense amount of questions using these techniques, topic wise, listed wise, year wise are given with solutions, and they will help you to clear the I.S.I exam. Now one thing very important about the I.S.I exam is that how you write your proofs properly. For that you need to visit the website of Ivan Shen, in which there is given the English PDF. So you need to download that PDF and you will see proof writing techniques clearly. This is because I.S.I professors, the persons who check I.S.I papers, usually cut marks for improper reasoning, improper writing. So please, if you don't know a solution of a subjective questions, leave it, but don't give improper reasoning. I.S.I is basically an independent body which can increase or decrease marks on their own, which can even offer you negative marks in subjective for writing incorrect answers. So please be careful and get your materials from Saurav's classes right now to excel in I.S.I. All the best for your exams. Hope you all be well. So meeting you again. Till then, goodbye and stay well.